Topic 4.2, we're going to find the asymptotes of a rational function. So we are now given a function, and in the denominator you have a quadratic. We want to find the vertical asymptote. Well, in order to find the vertical asymptote, we have to find the values of x that make our denominator 0, which would in turn make the function undefined. So what I'm going to do is I'm going to take this denominator and I'm going to set it equal to 0 to solve. Well, in order to solve a quadratic, I need to factor it. I'm going to put my two sets of parentheses in. I know I'm going to have to start off by dropping in my x's. X times x is going to give me that x squared. My c value is positive. That tells me my signs of my factors have to be the same. So if I look at my middle term, that tells me what they're going to be. And now I just have to ask myself, well, what two numbers, when I multiply them, I get a positive 12, and I add them, I get a positive 7. Well, that would be 3 and 4. I'm now factored. Once I'm factored, I'm going to use the zero product property again to solve. I'm going to set each factor to 0, and now solve. X equals -3, x equals -4. So I have possible vertical asymptotes at x equals -3 and x equals -4. Now let's talk about finding the horizontal asymptote. We have some little tricks that you can use to get at those asymptotes. So here we go. Let's title this Find the HA. So we're going to have a few different cases. Case 1. We're going to look at the degree of the numerator and the degree of the denominator. So here in case 1, the degree of the numerator is going to be less than the degree of denominator. If this is the case, y equals 0. So if we go back here, take a look at this. Let me jot it down again. F of x equals 3x minus 2 all over x squared plus 7x plus 12. So if we compare the degree of the numerator, the degree of my numerator (1), and the degree of my denominator, well, it's quadratic, degree 2. So 1 is less than 2, so therefore y equals 0. So my horizontal asymptote for the original problem that we started with is going to be y equals 0. Let's look at another case. Case 2. We'll say the degree of the numerator is greater than the degree of the denominator. This means you have no horizontal asymptote. So for example, if we do f of x equals x squared plus 1 all over x plus 2. So my degree of my numerator is 2, and the degree of my denominator is 1. Well, 2 is greater than 1. Therefore, there is no horizontal asymptote. And now let's look at case 3. We'll say the degree of the numerator is equal to the degree of the denominator. So if that is the case, your horizontal asymptote is the ratio of your leading coefficients. So let's do an example. If I give you f of x equals 2x squared plus x plus 1 all over x squared minus 1. Okay, so we have degree of 2 and another degree of 2. Well, now I need to compare my leading coefficients. Leading coefficient is 2. Leading coefficient is 1. So that means my horizontal asymptote is y equals 2 over 1, which reduces down to 2. Let's do some examples. So let's find the asymptotes. If I give you, this is going to be A in your triads, g of x equals 2x squared plus x minus 9 all over x squared minus 2x minus 8. To find my vertical asymptote, I'm going to take my denominator and set it equal to 0. Okay, now let's factor. I'm going to drop my x's in. My c value is negative, so that means my signs have to be different. So two numbers, when I multiply them, I get negative 8, but when I add them, I get a negative 2. Well, that would be a negative 4 and a positive 2. I'm going to set my factors equal to 0 to solve using the zero product property. I'm going to subtract the 2. X equals negative 2, and here x equals 4. So these are my vertical asymptotes. Now let's take a look at the horizontal asymptotes. So I have degree of 2 over degree of 2. Which means I need to do this as a ratio of my leading coefficients. So I have a LC of 2 over an LC of 1. So therefore, y equals 2 over 1, and that reduces down to 2. So my horizontal asymptote is at y equals 2.